Good morning to everyone. We are Today we are going to see about QR decomposition. QR decomposition expresses a matrix C as a product of two matrices, that is A is equal to Q into R. Where Q matrix is orthogonal or orthonormal matrix, meaning that Q transpose dot Q is equal to identity matrix, and R is an upper triangular matrix. So to do QR decomposition, first we have to input numpy as NP as the first step, and second step is to create a function that is def of QR decomposition of A, and third step is initialization of matrices, that is we use n comma m is equal to a dot shape, and we store intermediate values in following matrix, that is q, u, and r. Q is equal to np dot mt of n comma m, where we store orthogonal matrix, and u is equal to np dot mt of n comma m, where we store intermediate values in the process, and r is equal to np dot zeros of R is equal to np dot zeros of n comma n, where we store upper triangular matrix. In this next step is to find a first vector of Q. The first vector of Q, the first column of the matrix A is copied into U square bracket common semicolon comma 0, which is equal to A square bracket colon comma 0, and it is to be normalized, it is to be converted into a unit vector. So we are using the following line of code, that is Q square bracket colon comma 0, which is equal to U square bracket colon comma 0 by np dot linear algebra dot norm of U square bracket colon comma 0. The third step or next step is for loop for other columns, that is for I in range of 1 comma n colon U square bracket colon comma I, which is equal to A square bracket colon comma I, and for j in range of n, that is Q square bracket I comma I minus is equal to A of square bracket colon comma I at Q square bracket colon comma j into Q square bracket colon comma j, and Q square bracket I comma colon comma I, which is equal to U square bracket colon comma I by linear np dot linear algebra dot norm of U square bracket colon comma I. In this, the ith column of A is initially copied to U square bracket colon comma I. Then for each previous column, J for Q, the projection of U colon comma I onto Q square bracket colon comma J is subtracted, and remove any component in U square bracket colon comma I. That line along with the direction Q square bracket colon comma J, ensuring orthogonality. After organized After orthogonally, the vector is normalized to make it into a unit vector. And the result is stored in ith column of Q. Next step is computation of matrix R. After all the orthogonal columns of Q are computed, we can find matrix R, which is a upper triangular matrix. Each element of R is a dot product of columns of A and corresponding column of Q. So we run for I in range of n and for j in range of I comma m, where R square bracket I comma j is equal to A square bracket colon comma j at Q square bracket colon comma I. Here R square bracket colon comma I comma j is computed at the dot product of column j of A and column I of Q, which correspond to the upper triangular matrix R. Next, this is our last process, that we are printing our Q matrix and R matrix, where print the Q matrix as the Q matrix is the matrix Q, and the R matrix is matrix R. At last, we are getting matrix A as an input, that is in the form of A is equal to np dot array of inval of input, and we are calling the function. So we now will run this code. It takes time for running. We'll wait. The code has successfully run and we are giving input as 1 comma 1 comma 0 and 1 comma 0 comma 1 and 0 comma 1 comma 1. Now we have successfully given an input which shows error. We'll, we'll check what is the error. On the error, that is we miss commas. So we again run the code. We give input 1 comma 1 comma 0 and 1 comma 0 comma 1 and 0 comma 1 comma 1. Now now the input has been given. We will press enter. Yeah. Now we can see that Q matrix is printed and R matrix is printed. So we'll end this.